Good afternoon, everybody. Just real quick before we kick off, I just want to get a sense of the audience. How many people would consider themselves primarily in production? Just quick raise of hands. All right, not very many. Post-production? And if we consider visual effects as its own unique category, what would you guys, hands on visual effects? All right, and the rest of you are just in the wrong symposium, supposed to be across the street maybe? If you think about what we do, we spend a lot of time helping production, post-production, visual effects companies create content. And I think what's changing with the cloud today, with great partners like AWS, is that the beginning phase was this, as Chris described earlier, this heavy lifting phase, right? Hey, I have so much of a rendering farm, and if I can just offload the last 20%, I can keep my CapEx model, sane. The next phase was, hey, if I win that commercial or that feature, I don't have the capacity in-house to actually do that work. And the last phase, I think, is the democratization of this capability, meaning making it available for every artist, every professional engineer in our industry, so they can work from Portland, or they can work from Chicago, or they can work from Phoenix, or they can pop out of their son's birthday on a Saturday afternoon and get some work done and get back into that vacation or that party or whatever. So anyway, so just a quick intro from me. What do? We connect storytellers. We have a network today primarily that is in most places where media production exists, right? So we like to believe that we are where our customers need us to be. I'm sure there are some places you guys could think of that we're not. How that impacts virtual workstations, it's a direct connect challenge, right? So when you think about this, what are the challenges that you face? They primarily come in two flavors on the tech side, latency and contention, right? But on the practical side, it's all kinds of things. Like, what's the sense in having a virtual cloud minute in the sense of a GPU or CPU if you have to buy a 12-month connection? That doesn't seem exactly congruent to your bursting cloud model, right? How do you get all that done at scale in different cities around the world, and hopefully at some point remotely, meaning individuals in different places around the world? So there's a couple different things we do, right, to help with that status. One is, we provide all the technical capability, but probably most importantly, we allow you to buy it by the drink. So as Jason was saying earlier, you can turn it off. You can literally, the most common use case for us is a customer calls in, they need 10 gigs for a week in a specific city somewhere in the world to a specific on-ramp, and then they turn it off because either that commercial is done, that portion of the feature where they went over their internal rendering capability is done, and they're back to whatever their previous state was, right? The second thing we do is we provide expertise on getting you to scale. So the most common question when somebody calls in is I don't know what I need. I don't know if I need 1 gig or 10 gigs or 12 gigs or 30 gigs. And so our engineers work with our customers to get them to a certain sort of throughput state, sustained throughput, and then we can lock in that capability for the time frame that they need, right? And perhaps the most important thing that they need is the security piece. Every one of your customers has a different security profile, right? So if you're working with the Disney, Marvel, Lucas universe, their security requirements are different than WB, than Universal, et cetera, right? And we're well versed in how that works to make sure that you can get up and running, again, as quickly as everyone else wants you to get up and running. Perhaps the most important part of this slide is latency. So we talked earlier about latency and contention, right? The team here is going to tell you today that you need to be on a 25 milliseconds to make Teradici work well, okay? Think of it as the higher your latency number, the more your artists pushing on a Wacom tablet feels like a drunken sailor, right? The better that responsiveness is, the more sort of precise they can be, right? And the better their experience as an artist is, right? The last thing you want is your employees or your professionals to believe that your solution doesn't work well, that it's second rate, right? So as you can see with our partners at AWS, we have incredibly low latency, gives you some cushion to be in other cities close to those on-ramps where their production facilities are. The second piece, again, comes back to contention, right? Remember, the internet has this unfortunate consequence of it's kind of a best efforts approach, right? So you can buy 10 gigs of internet and even have a provider who might actually give you 10 gigs of access to the local peer point, but you may quickly be cut down because of internet traffic to some number dramatically less than 10. And as we all know, there's two challenges with contention. One, your packets get dropped, which means they need to be retransmitted, right? That sort of churn, especially at distance, combined with latency, is what creates all your crazy connectivity problems. So the best way to avoid that, of course, is to not go on the internet, right? To have an appropriate, private, dedicated capability that you can then scale up at an economical pace and turn off when you're done. So very quickly, we're not going to talk about render today, store and access. So we're not going to talk about all the great stuff that Jungle Book's done, or the capability to back up anywhere, or the access that some of our customers done, but specifically workstations. Again, Teradici is going to be up here in a minute, and they're going to talk about 25 milliseconds being this sort of minimum point to have a good experience on their service, right? You need to be able to pump up the bandwidth, right? So imagine we talked, Chris earlier talked about a truckload of servers, and Jason talked about how would you add 1,000 servers overnight. Today, as you guys have seen in workflows, there are people like, hey, I got to add 300 people to my project, right? People still go through. There was some poor engineer in Vancouver, in Montreal today, who was running around trying to figure out how to rent 300 workstations for a week or 3 weeks and go through the terrible sysadmin nightmare of configuring them all to be set up for those artists, for security, et cetera, right? And you need to be able to change. You need to be able to make the decision of, I know I assigned that project to Vancouver, but for whatever reason, I need to move it to Montreal, and not have to significantly change the way your workflow works, your render pipeline, okay? And obviously, security audits are always a thing, okay? The scaling piece is important. Again, it's the ability for you at a workstation level to constantly be able to grow up and grow down, right? And our big lessons that we would suggest are run your trials before you have a problem. As Jason was saying earlier, you don't want to wait until the day you need 1,000 new servers to figure out how to get it done. So do an experiment. Put 10% of your artists or your engineers on a virtual workstation. Work out the kinks. Figure out your workflow. Do it at a low capability. Then when the crunch time comes and you really need to add a project and you need to put 500 people on it, it's just about scaling an operation, not about figuring out a new laboratory experiment in the process. So we have some great partners who are going to follow me at both Teradici and AWS at the end. Come on up. And then we're available if you have any questions. I have some smart engineers in the room who can answer any questions you have about how to get this done. And I will hand off to Ian.
That sounds better. So just by show of hands, who is not familiar with Teradici at all? Okay, so most of you have heard of us, but I'm technical marketing principal at Teradici, and that's sort of the proportion of gray in my hair since I joined back in 2004 or so. We started out as a silicon company providing hardware encoding for remote workstations, typically on premises, to thin client or zero client technology, which many of you in the VFX industry at least are used to. But over the last years, our company's evolved to an enterprise software company, and we started our relationship with AWS back in 2014, where if you're familiar with Amazon Workspaces, that incorporates the PCoIP protocol, which is the protocol that was originally in our silicon product and then turned into a software on the host side. And now, as it's continued to evolve, you can go to Marketplace and grab an AMI instance with Teradici's Cloud Access software, and you can just get it and roll your own. And on the client side, you could be using our Zero clients or software clients on Mac or PC or iPads or OS X. So a broad range of products that we offer now. And the PCoIP protocol, the marketing requirements here, the highest performance, and that's why it's such a popular product inside of the media and entertainment industry. You don't want to have artifacts, you want to have color accuracy. And then there's a security question on both the client side. You can have an isolated stateless endpoint, and then on the host side, how do you isolate your content network? And I've got a slide later on that talks a bit more about security. And then, of course, we need the flexibility. People are using Windows and Linux. They're using the original workstation cards. They're using software on premises. And now we're in this exciting phase moving to public cloud. So you need a protocol that supports all those different environments. Just on the last topic of performance there, these days there's lots of different ways you can remote a workstation, but the PCoIP protocol is the only one where you preserve this color accuracy, and we have this thing called build to lossless so that artists aren't guessing as to the color that's on their display. It's the actual color that's rendered on the host side, and that's really important. If you use a video codec, you may get lower bandwidth and smooth frame rate, but the color rendering is not the true color that is happening on the host side. So I think Chuck and Jason have already touched on all these great reasons why the public cloud is so compelling, especially for the render side. We can move to this OpEx model, which is much more in line. We can start having our artists in different geographic regions, which means we can take advantage of tax credits in different places. We can get rid of these really expensive data centers that are in London and Montreal, Vancouver, here in LA, and start moving those out to public cloud territory. And then, of course, you can do all that with the PCoIP protocols, including the security and the performance that you're used to in your on-premise facility. So this is just a pictorial of the vision that we see of people migrating from what was originally an under-the-desk workstation, lots of heat, security management issues, and they need to be replaced every few years. So many studios have evolved away to sort of a remote environment where they're using remote workstation cards in their own private data center. So that's a very popular model. But now we're moving towards a software equivalent where, as I said, we now, instead of having this hardware encoder on the host side, we're able to use a software renderer, which gives us this future-proofness when HDR and 4K and all these new formats come out. And the last step is to this public cloud. So this migration, people don't go from one to the other. We have some studios going direct to public cloud, but there's typically a hybrid environment in the meantime, in the interim, because you want to make sure you amortize all your capital expenses that you've already invested into your on-premise infrastructure. So that's an important consideration. So our customers are using a broad mix of these different solutions out there. This is a schematic of what a hybrid solution would look like. So starting with your on-premise facility could be host cards or this cloud access software. And as Jason spoke to, well, you have this render farm, but that's really fixed in size. And then from a workstation point of view, many of our customers go take these workstations and they feed them into the render farms when they're not operational, which involves complex pipeline work so that when artists aren't working, you can actually use those machines for rendering. Of course, when you move to the public cloud, you can have the scalable render, which has already been talked about, but you also have, besides this bursting of artists, you have power control at a very low level, so you can turn these machines on and off and not incur any costs while you're not running them. And of course, you don't need to move this data back to the facility to look at it, so you don't incur that time delay and security of having this content going backwards and forwards. So another schematic, which is a new product which I wanted to talk about, that was, it launched earlier this year, a Cloud Access Manager, which is a service that Teradici offers to broker remote workstations. Now, many of our customers have direct connections between the endpoints and their dedicated virtual workstations. Some use third-party brokers, and some actually have built their own brokers. So Teradici built a broker system. And as of, I believe, next month, you will be able to put that broker onto your on-premises environment, which means that your local artists can either be brokered to local machines or through a connection into AWS. And the next step after that is we will be, so the issue is local artists can use cloud workstations, but if you're wanting to support different regions where people get access to the closest cloud, you want to have an access point directly in. So we will be adding this cloud connector into the AWS, and that means in a global company, your artists can all access their local cloud facility. And we're also, for those of you who have already invested in remote workstation cards, this broker component will also broker coming up the remote workstation cards. So you get this full breadth of brokering across all the resources. This is just a quick GUI of the user interface for you people to understand. You've got artists connect to resources. There's also a capability to provision and configure the machines themselves. Those are all built into the Cloud Access Manager. And then touching on security, so PCoIP protocol lives large in a lot of the big studios. They all go through their security audits. And that's because we have an encrypted pixel stream which allows you to isolate your content network from the broader public internet, which is the requirement to get any of these studio certifications. So we have an isolated network, but what some don't know is that to still give artists access to resources outside of the secure network, you can actually put a client, PCoIP client inside of that secure network and have a reverse connection out to a less secure desktop to access resources. So you can still maintain your content security through two back-to-back PCoIP connections. The last question we come up often is around the performance side. So Chuck's already touched on the latency side. The other side of performance, which we get a lot, of course, is what's the bandwidth needed for all of this. And unfortunately, it's not a one-size-fits-all because it depends on your display topology, your resolution, what's the use case. Are you doing editorial work or animation or rotoscoping? Those all have different bandwidth profiles. This is a studio over 60 artists, and we're working just over 5 megabits per second on average. So while the burst requirement for each individual user may be quite high, because the protocol is not generating any traffic when people aren't actually have high activity when there's low activity on the display, there's very low bandwidth demand. So it all evens out to a pretty reasonable bandwidth demand. And that's it. So I'll be out in the back later on if you have any questions. And in the interim, I'm going to pass it over to Bobo from AWS, who's going to tell you more about the AWS infrastructure for this. Thank you.
Thank you. Do you hear me? How is the audio? Good? OK, thank you. All right. So my presentation is actually the easiest because a lot of the important points were already made by the speakers before me. My name is Borisław Petrov. Everybody knows me as Bobo. I'm a solutions architect for AWS ThinkBox. And in a previous life, I was technical director of visual effects at Frantic Films, which Chris Bond founded, mentioned previously. But let's talk about the workstations and cover a few details on the technical side from the AWS perspective. Obviously, we talk to many customers like you, and what they are usually asking for is they want to be able to run virtual workstations, typically with Linux, with CentOS, but I would guess that a large number of customers actually also run Windows for software reasons or for historical reasons. Can I get a show of hands how many people actually use Windows here? Yeah, approximately what I would expect. So as mentioned, the solutions actually cover both Windows and Linux in the case of Teradici, so that's very helpful. Though HD monitors are a requirement, anything less than that wouldn't really work in practice. The color and pixel accuracy that was just mentioned is paramount. You cannot really do any work in visual effects without being able to tell what color a pixel is. And the video and audio synchronization is very important because if you're playing back a video and you're listening to the source, there shouldn't be any discrepancies there, and you should get exactly what you would expect from a local machine. And then probably the trickiest part, from my point of view, is actually the Wacom spot. because there's so many models and driver versions and some newer versions that support new features that can cause headache if you're not careful. For example, the 8K versus 2K pressure. The newest Wacom tablets actually have 8K pressure sensitivity, but some of the older drivers don't know about it, and some software, it's not even programmed to support that, so I have to set certain settings and switches to allow for that. People have tried it themselves, and they turned to us for a solution, and together with Sohonet and Teradici, we think we have put together all the pieces of the puzzle to actually get something that works exactly as requested. So I won't spend too much time on why, because a lot was said about it, specifically the scaling of artists, just like you scale compute resources. With AWS, you can add thousands of render nodes, but when you have to add artists, which costs probably even more than that, and they are scattered around the world, or they are available only to work from home, or they're currently in Hawaii on vacation, but you still want to use their abilities and so on. It's actually very easy to access if they have a workspace that they can access in the cloud. And this way you can actually build a pop-up studio. In fact, we have some customers of AWS that are completely decentralized, and they can create a studio whenever a project comes and work, and then shut it down again. Just like Jason was talking about, that's the best part of all. Again, Jason mentioned it. It's really nice to talk after so many speakers where pretty much everything was covered, but the problem of data synchronization, which can be a headache with huge amounts, with petabytes of data that has to travel between on-premise and the cloud in order to make sure that render nodes in the cloud have all the data. And on-premise machines also have the same data. Once everything is at the cloud, the problem is solved, really. You have the workstation, you have the storage, you have the render nodes. Everything is in one area, and there is no need to push anything but the Teradici pixels back to the desktop. And this slide actually was originally written by my colleague, Mike Cohen, who is in London. And he mentioned Brexit specifically and smiled at this point and said, well, we beat Brexit with this. But it's actually true for other places where tax credits, for example, in Canada and many places, you might have workforce that is in Vancouver or Montreal and make use of the tax credits because you have workforce there without actually having to create a studio there. And there are some locations in the world where power, I think Los Angeles might be also one of those, but power can be a concern when you have to install hundreds of additional machines. And London and New York City and so on have had problems where you start a studio and studio stops because you cannot actually feed the machines with electricity. Talking about that, actually, not only you save space in the company on the floor, you reduce the heat emission, which is great for most places in the world, except for probably Winnipeg, where our company was started, because I remember I was living there at -40 outside, and all the computers were blazing hot, and I was sleeping pretty much next to the workstation. That was probably an exception of the rule. But in general, I would like to remove all those workstations from underneath your desk and have only the zero client, the monitors, the keyboards, mouse, tablet, and forget about all those bulky machines sitting around and emitting heat. There are lots of instance types on AWS, and there are a few that are very useful for GPU rendering and for remote workstations, or for workstation work in general. And the good news is that almost every year, those instance types are actually being renewed. And it means that if you purchase a machine today, you might have to use it for 3 or 4 years if it's yours, but on AWS, you're just renting the type of machine that you need today, and if tomorrow a better machine comes, it might even be cheaper, and that's not, it has happened before, where the next generation of compute instances are actually cheaper than the previous generation, and faster on top of that. So you're not really locked into a specific type of hardware, you can switch it within 3 minutes. Or at least that's the time that it takes from my connection at home to connect to a new, spin up a new machine and start using it. Okay, actually I spent a lot of time on this one, but it's kind of important. Again, Jason mentioned the global studio and the global pipeline, and I think that's obvious. This slide is actually part of blog that Mike Owen has released recently, and I'm going to show you the last slide with the URL to that, and you can search on the internet and read a very detailed explanation of all the steps needed to create a workstation. But this basically explains the, oops, I went too far. Or better, I actually clicked the wrong clicker. Where am I? Okay, sorry about that. I got it. So 2 types of users again, where we represent a Windows user and a Linux user, which might have slightly different setups, possibly different setups on the on-premise side, but also different setup in the cloud. For example, typically, you probably know better than me that you might have a centralized repository of all the software that will be running on the machine, and whenever you spin up the machine, then you synchronize the necessary tools that will be used, while on Windows you might actually have an Amazon machine image that already has the necessary software installed, 3ds Max and Adobe products and so on. So different variations of a theme, but in general, direct connect in between, which would be Sohonet in this case, and the Cloud Access Manager that was mentioned can broker which user will be using which machine, and the Cloud Access software, which is streaming the pixels to the Zero client and from there to the monitors. So this is the general schematic, and there is, unfortunately, we don't have a picture with 2 monitors. We were asking around if somebody can supply one quickly to replace in this presentation, because this is, I suspect that Mike Owen took a picture himself and put it in the presentation originally, and we are now, we should update this in order to represent the real situation. But the important thing here is what are the requirements in order to get this working? Obviously, CPUs should be modern and fast and plentiful. RAM for a workstation, probably 128 gigs is kind of the minimum nowadays. GPUs, or GPU at least one, but potentially more, depending on whether you're using only acceleration for the viewports or actually rendering with GPU renderers like the ones that will be discussed in the next presentation. Fast network and disk I/O, and obviously the PCoIP Zero client. And users expect from those components to actually deliver great image quality, high frame rate, and low interactive latency. As mentioned a few minutes ago, the latency is the key to the actual experience. We are talking about various numbers here, and in theory, a Wacom tablet could be useful with less than 25 milliseconds latency. And if it's around there, then local termination becomes a necessity. And local termination was supported on the hardware cards of Teradici in the past, and a lot of customers are actually running this, where the USB input is being processed by the Zero client, and only the necessary results are sent as a much more compact stream to the workstation, to the remote workstation. But currently, this is supported with the software version of the CAS, the Cloud Access software for Linux, and for Windows is currently being worked on, and it's on the roadmap, so it will happen soon. Obviously, since speed of light is still an issue and will be for a while, except in science fiction, we have to think about what is the closest region that is relative to the office that we're connecting, and we're connecting to, and there are thankfully a lot of AWS regions around the world, and more are popping up every year. So a few regions to consider, and you have to think not only about the location, but also potentially the size and There might be even implications to the cost, because the larger regions tend to even have much lower prices of compute resources. Typically for the West Coast, Oregon and Northern California are very important, because for Los Angeles, Northern California, San Francisco is the closest region. For Vancouver, for example, Oregon is a better solution, and it's huge. The largest one is Northern Virginia, actually, in North America, or worldwide, really. So for the East Coast, New York and so on, that becomes interesting. And Montreal, of course, for Canadian studios that are in the region around Montreal and Toronto, that is the one. And in Europe, Dublin is the equivalent of Northern Virginia, more or less, for Europe. It is vast, has a lot of resources, and it's actually very comfortably usable from most of the Western European countries. However, if you're in London or Paris, you have a local region that would give you a significantly lower latency, but you have to see if it can cover the needs for capacity. Because you have to keep in mind that when you put in a workstation somewhere, it's a good idea to be in the same region as your render resources and storage. Otherwise, you're going to incur costs of transferring data between regions. So it's not only picking the right region for the workstations, but picking the right region to keep as much as possible together. Of course, with the global studio, you're probably still syncing data between, let's say, Europe and East Coast and West Coast and so on. But if you don't have to, you better not introduce an additional complexity. Now, these numbers are not official and are not promised. They are just numbers that we have from customers that have tried to run this and reported what latency they're seeing. In fact, I was in Tokyo and I looked at the screen while we were pinging a machine in the cloud through Direct Connect, and it was 2 milliseconds. And the same is true for pretty much any of the regions that has a Direct Connect to the closest region in that city, like London and Montreal and Sydney, and 2 to 3 milliseconds. Over public internet, it would be 10. In both cases, it's actually very comfortable to use for remote workstation with a Wacom tablet. Los Angeles to Northern California is a little bit higher, but with Direct Connect, it's actually, again, comfortable. And if you add local termination, it's not a non-issue. Going from here to Oregon, though, it becomes necessary to actually run local termination in order to get a good experience for the artist. And Vancouver to Oregon is close enough. Again, with Direct Connect, is actually a very good distance. And of course, if you have the ability to run local termination, you should be doing it anyway, no matter how fast your connection is, because why send more data if you can send less? Again, we don't guarantee those numbers, but those are actual from the field reports. So take them with a grain of salt, but you should experience something similar. Now, the EC2 workstation types that are potentially or typically used, there are some more GPU instances that could be used, but this is the current generation of general purpose GPU instances. The G3. The G3 has 3 sizes currently, 4x large, 8x large, and 16x large. As a rule of thumb, if you're not an avid AWS user, you multiply the number in front of the X large by 4 in order to get the number of virtual CPUs that you have in the machine. So as you can see here on the side, we have 16, 32, and 64, which is pretty much 4 times this number. They have doubled the RAM with each increase of the size. So it starts with 122 gigs of RAM, 244 and 488. They have 1, 2, or 4 GPUs. In fact, the chassis actually has 2 M60 Tesla cards in it, Tesla M60. Each one has 2 GPUs. When you're running a 4X large, you're running pretty much on 1 GPU of the card, half of a card. The 8X large is running 2 GPUs on it. And in fact, if you run the Octane bench on 4X large and 8X large, you're going to get exactly perfectly double the performance. When I run it, I got 78 and 156 or something, whatever the double of it is. I'm not good at math. I have computers for that. So if you really need the GPU only for the viewports on the workstation, it makes little sense to go to a larger instance type because you'll be spending money on additional CPUs and additional RAM and additional GPUs that you might not use. However, if you're rendering with Redshift or Octane or another GPU accelerated renderer, then a larger instance can be launched at any time when you need that, and then you can go back to the 4x large to do your everyday job in Maya or 3ds Max or Nuke or whatever. Now, these machines have actually relatively modern and fast and turbo boostable CPUs. So if you have to do general computing and not GPU-based, they are pretty good. With the 16 2.3 gigahertz, which can be actually pretty much all the cores of that machine can be bursted to 2.7 gigahertz, and you can run through at 3 gigahertz at once. So in this configuration, we have grid license drivers. Basically, NVIDIA grid drivers are provided with the Amazon machine image that you deploy, and you can run up to 4 monitors with 4K resolution. Now, of course, with your Zero client, you have to be careful because I believe that the previous generation or the current kind of popular Zero clients that you might have on your desk might not support more than 2K, but you might need a new Zero client to support 4K, but Teradici supports 4K on 2 monitors as far as I know. You correct me if I'm wrong. So a little bit about the pricing. I'm looking only at the G3 4X large instance type here, which is probably the workhorse for most of the users. Using the on-demand pricing, which means pay as you go, you get it, you run it for whatever time. If it's running Linux, it will be charged per second. So you run it for 10 minutes and you shut it down, you pay for those 10 minutes. The price is $1.14 per hour in both Oregon and in Northern Virginia. However, the price is a little bit higher in San Francisco. So we calculated in a very optimistic model where we assume that an artist is working only 10 hours a day, 5 days a week, which you know might be a fairy tale. But let's assume that these are the numbers. In that case, it would cost $247 per month on Linux, significantly more on Windows, because this actually incurs licensing costs for Microsoft Windows per CPU. You can even calculate how much that cost is by taking those numbers, and you're going to see that 73 cents, which comes to 4.6 cents per hour per CPU. But that's a small detail because a lot of you will probably be running Linux and will get the lower cost for that. And there is an additional cost for the Teradici Cloud Access software. You can pay as you go at 50 cents per hour. However, if you intend to run for a very long time, like a whole year, you can buy it at, I believe it's something like 95% cheaper. It comes to $240 per year per EC2 instance. If you go and calculate how much this would be for a whole year, it's in the thousands of dollars. So generally, you'll probably like to have a whole year commitment for Teradici. And there is an additional cost involved when moving data out of AWS. Ingesting data into AWS costs nothing, but when you're streaming the pixels from Teradici, you're going to have some tiny costs involved here, which is 2 cents per gigabyte. That's the egress charges. I believe it's a drop in the bucket compared to all the other costs there, but it's something still to keep in mind depending on how much. If you're working with video, for example, the bandwidth that you need will be obviously hard than just rotating viewports or looking at text and so on. There are some technical details here that we are offering about that G3 4X large. Basically, there is AWS community-based Amazon machine image with CentOS 7.4 that we use when we're testing. You can use 7.5. It's as the VFX platform compliant one, and we have listed the kernel and compilers and so on. But this is basically information about our proof of concept original test as we installed all the drivers. It is a necessity to actually run a higher version than this of the grid drivers. This was the latest at the time when we were creating this presentation. And Teradici, the Cloud Access Software 2.12, is the current stable one, which actually has an increased default frame rate of 60 FPS and includes improvements in the performance on multi-display systems. One of the displays is idle. You can imagine your artist having Facebook open on the one monitor and actually working on the other one. That monitor won't incur any transfer cost really, because it's static and nothing is changing it. In general, with Teradici, I probably don't have to explain to you, but just in case, because was mentioned previously, different codecs are being used for different content, so depending on what is happening in a certain application or window and so on, I might use a different encoding, a different codec to actually stream video and stream text and stream various contents in order to reduce the bandwidth load as much as possible. The driver, the Wacom X driver, we used 0.39 in our test, but 35 is the minimum requirement because it has the pressure to K environment variable. As mentioned earlier, if you try to start Nuke without this set to true, it's going to crash pretty much, at least when we tried. It might have been fixed in the meantime, but it's something that newest tablets support, and you need to pretend that it's an older style tablet in some cases. For some applications, you set this flag, and it basically forces the 8K to be transferred to 2K for the applications, so they don't get confused. I would like to mention here, this is not directly related to the workstation, but we were talking about GPU rendering, and in fact, when we were testing our workstations with the G3s, we decided to take a look at the P3s and see what it does. And the P3s actually runs the latest and fastest NVIDIA GPU, the Volta 100, which has up to, well, it has actually 8 GPUs on it, which NVLink cross-connected. Each one can talk to each one of the others. So basically, that's the one card. It costs $120,000 just the card. And you can rent a P3 2x large, which gives you only one of those GPUs. And of course, in that case, no NVLink is needed because it's not linked to anything. Each one of them has 16 gigs of memory. So on 8 GPUs, you actually get 128 gigs of video memory. And these are the cores that I have put on the site just to compare. And of course, the performance when rendering with GPU renderers is respectively higher. In fact, we tested a redshift scene, which was testing on the G3 4x large that we're running on, rendered in something like 12 minutes. It took 19 seconds on the P3 16x large. So it's not exactly the real time in this case, but it's getting there. And I just want to mention them. In this case, though, there are some complications because, I pretty much run out of time, but I'm pretty much done. Just wanted to mention here, since you would have to install your own NVIDIA driver in order to get those P3 instances to work for rendering. Typically, you would use them as render machines and probably not as workstations. They're generally meant for machine learning and AI, so they're very sought after and rather difficult to find and very expensive. The price, I believe, of this one, the P3 16x large, is something like $24 an hour, but still it beats $120,000 that you would have spent just to get that card if you could. And those cards are not meant for you, they are meant for cloud usage, so really difficult to find one. Now, on the AWS Marketplace, there are 2 Teradici Amazon machine images, one with CentOS 7.5 and one with Windows Server 2016. And you can start with them. You can basically spin up an instance with them and then install the software that you need. But the cloud access software is already pre-installed there, and you only have to enter the necessary information in order to get it licensed. If you want to try it, if you want to make it real, we offer support and from both AWS and from our partners to get you going. We give AWS usage credits, so you don't have to spend your money in order to see how it works in the cloud. You're going to get trial licenses for Teradici Cloud Access software. Sohonet Media Network has a trial license for Fastlane. Autodesk is supporting us for running the workstation software, Maya, 3ds Max, and so on the workstations, and they're on board with this. And we have a dedicated support team for this. So if you want to try, talk to us. I'll finish in a second, and we can have a conversation around here. I mentioned the blog. It was posted probably about a week ago or two by Maya Cohen, which is my counterpart in London, the solutions architect for ThinkBox. And if you just search for building GPU workstation, you're probably going to find this article, and it goes into minute details about every single setting that is being done for Windows and for Linux. You can build it yourself. A lot of you might be doing it yourself, guys that like running installation scripts and so on. But we're also working on providing quick start templates, so basically we can spin up all the necessary components, install the right drivers, and make all the right connections in order to get this working for you. But this gives you really the fine detail how to do things. Thank you very much for staying 3 minutes over, because there is a little bit pause now. And thanks to our partners, Teradici and Sohonet, for joining us on stage. We are also doing presentations from time to time, going around the country and the countries. In fact, I was to one in Vancouver, and I did one in Los Angeles a few months ago. So we might continue doing this if you want to actually attend one of the practical demos. We don't have Sohonet here, so we are not really running it live. But I would say it's probably the best to go and do a proof of concept and try it yourself and see how it works. So talk to us, and we'll figure out the next steps.